is an extension of our lesson on special right triangles. Last time we did a study of 45, 45, 90 right triangles. Now since it's a right triangle, that takes care of the 90 part. The other two angles, and it has to be 30 degrees and 60 degrees. If you add them all up, you find out that you do get 180. So the special properties that we're going to be discussing having to do with these triangles all deal with triangles that have 30 in one corner, 60 in another corner, and 90 in the third corner. Okay, now if you remember from when we talked about the 45, 45, 90, there was a very special template that went along with it. So what I want to do is I want to define the special template for this type of triangle, and then we want to do a whole bunch of examples of how to use it. Okay? So first thing we need to do is we're going to label the angle that we're going to base everything off of, and that is going to be labeled S. And S is always going to be the angle that is the shortest side, and it's across from the 30 degrees. Okay, so S will be the shortest side.
Okay.
Okay, thank you.
Sorry.
So S is the shortest side. We can tell that because it's across from the 30. Okay? You should remember that across from the shortest side will be the smallest angle. So S is the shortest side on all of them. Over here, S would be right there, across from the 30. Always across from 30. Yep. Now, this part might be a little bit not natural to you. I'm not asking you to come up with it. I'm just asking you to understand that it's true. The hypotenuse is always going to be 2 times S. So 2 times as long as the short side, that's going to be our longest side. Right? So it almost looks like the math is going to be easier for this type. However, that leaves our third side. And the third side, the one that's across from the 60 degrees, will always be S times the square root of 3. Okay, S times the square root of 3. It's not too bad, okay, but you do have to understand this is our template. I want to show you why it works. Okay, in other words, I just want to plug it into a squared plus b squared equals c squared to show you that these proportions will always end up being equal. So let's do that. If we have a, you don't have to write this part down, but just please pay attention. I just want to show you that it always works for every 30, 60, 90 triangle. So we have Pythagorean theorem, a squared plus b squared equals c squared. Okay, Preston, which one's c squared? C. Hypotenuse, which is which on our picture? 2s. So we have 2s squared over here. And I want to check and see if it equals a squared plus b squared in this case. A can be which one, Alvin?
S.
S, sure.
S.
Or?
S square root of 3.
Or s square root of 3. So we'll just put s square root of 3 in the spot that we didn't use here. Okay? Now, even though it's variables, you can still do this pretty easily. S squared, we're going to leave as s squared. How much is s square root of 3 squared?
S squared.
Antonia?
3s. Wait, no,
3s
squared.
3s squared. S times s because of the squared. Square root of 3 times square root of 3 gives you 3. Remember, any square root squared gives you that number. Okay. So, Luke, how much is 2s squared?
4s squared.
4s squared. And look at this. 1s squared plus 3s squared does equal 4s squared. So, this will always work. Okay? This is your template. This is what you're going to need to write down every time you see a 30, 60, 90 triangle. You want to make it second nature so that eventually you're not actually writing it down, but you always see that in your brain. Okay? The biggest reason for teaching this, because there are other ways, but the biggest reason for teaching this is so that you begin to see it automatically and you save precious time on your SATs. I know I keep saying SATs, 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 but they're coming. There are dollars attached to SATs. There are dollars attached to SAT scores. There are college entrances attached to SAT scores. So you want to make sure that you achieve the best that you can. Okay, you may get into the school of your choice based on your SAT scores.
Can't be county.
Okay, now, let's look at an example here. We'll start with a simple one and we'll move into more and more difficult. So here is your initial problem that we're going to work our way through. So here we have A and B, all of the directions on all of the ones I'm giving you today say find A and B. In your homework, some of them are marked X and Y or C and D. Okay, this is a 9. Okay, 9, A, and B. All right, so just sketch that out. Now, you have this in your notes, so you don't have to redraw it every time, but I did put it in every corner. I put it in every corner for all these examples so that you have it. It's right here, and I can refer to it. So looking at this triangle, you always want to identify where is the known in your formula template here. 9 is which one? S. Does everybody see that?
Yes,
Does that make sense to everybody that 9 is in the S spot? So then we need to figure out the other sides. Okay, so that means that the 2S side would be how much? It's in the A spot, right? And it's what number? 2 times
B?
9. When you found S, you just plug in the number
Oh.
and then do the math. So 2 times 9, 18. Yeah, what's your question?
Yeah, I can't see that.
Alright, let me scoot this
Sorry.
a little bit. It's okay, you need to be able to see. There we go. Okay, so once you've found your side, multiply it by 2, that gives you 2S, which, Alvin, I think you were trying to tell me which letter that is on this. A. Okay, so A is 18, so we have that number. We have one more side of the triangle. We have S square root of 3.
So 9 square root of 3.
9 square root of 3.
That's just good.
And that one goes in B.
And the 18 and 9 square root of 3 is 3.
9 square root of 3 is still 9 square root of 3. We can't simplify it. We can't simplify it. I had to answer the question.
I was real smart.
We can't. If it was square root of 3 times square root of 3, you'd get 3. If it was the square root of 9, you would get 3. But 9 times the square root of 3 is its own thing. So I'm really glad we chose that example so that if you saw it somewhere else, you wouldn't get confused. All right? So here's our answers. Okay, that one was fairly simple. Let's get another one. It was.
Oh, you just gotta find
That was
A and
it.
B.
Find A and find B. We're done. Okay.
That's it?
Whoops.
Well,
So
that's
that
simple.
one's super easy. I started with the super easy. We'll build them up. Okay.
Curl. Jerry curl. Thank you.
Let's get another one. All right. We're trying to find A and B and 10. We're trying to find A and B. So what we do, always, you're going to go back to your template, you're going to find your 3 sides, and then just look on this to find out where they belong. Okay? So just jot down, the only thing you're really jotting down is this little triangle. It's got 30 here. you could very easily figure out the other one's 60. Okay? And we're given this side right now. On our template, Frankie,
Yes.
which side is the 10? Is it the S, the 2S, or the S square root of 3?
2s.
2S. So 2S is 10. Now, every time you identify one where you're not actually given S, the first thing you need to do is solve for S. So we want to solve for S. This is a super easy solving for S. S is 5. Okay, did we find one of our answers here?
Yeah.
Which one is S on this picture, Emily? B. So we found B. B equals 5. Okay, so we got our answer half figured out already. Then we have one more side. This is an S. Jessica, what is it?
5 square root of 3.
Good. So S square root of 3 in this case is 5 square root of 3. Jessica, which answer is that?
A.
A. So A is 5 square root of 3. Here's your answer right here. Okay. All right. So now, just like the 45, 49, 5, 90 was simple, it is. You just have to be very careful as you go through and solve. It's a little bit harder because we don't have matching ones this time, so there's always another step. But once you get this down with the template, you're good. There's no problem with that. Okay, let's do another one. Now I do have the orientation of the triangle changed a little bit, but it's still 30, 60, 90. So you just draw a quick right triangle, 30 in the corner, 7 here, A and B. It always helps when you're drawing a right triangle to start with the L and then just connect the corners. Alright, Kyle, which side is the 7 on our template? 7 is on the 2S side. Does everybody get that? Everybody see? Okay, if you don't, you have to tell me. Okay? Now, some of you, it would be very natural for a lot of you to say, oh, it's just 3.5. But I don't want any decimals in this. I don't even want any mixed numbers. And the reason is because our third side has a square root in it, and you have no idea how horrible it is for a math person to look at something that's a decimal and root mix. You just don't do it. So S is 7 halves. Yeah, 7 over 2, 7 halves. So since S is 7 halves, Duran, which one is that? It's B. Good. The one across from the 30. So we found B already. B is 7 halves. Okay, so even if it's a mixed number, that's good and as it should be. So we still have to get the third side. We still have to get the S square root of 3 side. So this is what A is going to be, this one. How much is S though? S is 7 halves, square root of 3. There's nothing that cancels out here. You can either write it like this, or another very common way that actually I think you'll see a little bit more often would be 7 square root of 3 over 2. You'll see this more often. I wouldn't take off for either one of these answers, but it's just a little bit more common to see it this way. But you should still know both and know that they mean the same thing. Okay? So if you have an odd number, it doesn't simplify down as nicely. The answer doesn't look as pretty, but it's still just as correct. So that's that one. Okay. I know I've got like a million examples here, but it's good for you so that you know how to do all different scenarios. Let's get another one. Once again, it's switched around a little bit. We still have a 30, 60, 90 triangle. Start by making your L, then connect the corners. This time, there's actually a root on one of the sides. Everybody's got a chance to write that down. Make sure that everybody's writing it down. Make sure you're writing down, okay? All right, Imani, which one is given? Which one is the 8 square root of 3 over here?
Is that 2s? Or s squared? I mean, yeah, s squared 3?
It's the s square root of 3 one. Notice that these are the legs. You have a long leg, you have a short leg. The hypotenuse is right here. The hypotenuse is the angled one across from the right angle. So this is the long leg across from the 60. So that's exactly why s square root of 3 is 8 square root of 3. Now this one's almost so easy that you don't have to show the step, because most of you just see what s is right off the bat, and that's fine. Okay, but if you want to know what we did to both sides, which will help you later, what do you do to both sides? Divide by the square root of 3. Squaring it would give you an s squared, so you don't have to go through all that. But we can just divide because s is multiplied. So when we divide by square root of 3, so s is 8. All right. So out of A and B, Grace, which one is 8? A or B?
A.
A, good. So A is 8. All right, then once you have that, it makes the other side, it makes B very easy to find, because what side, Rebecca, have we not used yet on this?
2s.
2s. So, Rebecca, how much is 2s for this one?
Hold on. Wait.
It is B, yeah.
Okay.
It's definitely B. How much is S?
30. No, 8.
8.
8. Oh, yeah,
So-
8. It's right there.
2 times
8. 16.
16. Okay, good. Good job. So B is 16. So once you find your S, use it to find the other missing pieces. Okay, good. So we have A is 8, B is 16. So we found A, found B, we're done. Now this one again is one that's not too difficult, because it's really the one right in this spot has the square root right with it. So you're really just identifying the S and then putting it in there. Earlier somebody made a very common mistake and said B was 4. Okay, because they accidentally forgot that they found the one that was here and you had to double it. So it is helpful to maybe put the numbers back in your picture so that you can see that they make sense. Because if you made a mistake like that, you did a common mistake, you divided when you should have multiplied, but you were to put your 4 here and your 8 here, you'd find out that one didn't even make sense, because this has to be the longest side, so it should be the biggest of the numbers. Okay, so use all the math you know to make sure you can go back and check carefully. All right, let's move to another one. This one will be a little bit more challenging. Harry, which side on the template? Which one's the 6? Out of this, and this. S, 2S, S square root of 3, which one's the 6?
S squared 3.
Good, S square root of 3. So S square root of 3 equals 6. Harry, what can you do to both sides to get S by itself? You're doing fine. Divide by, good. I'm watching you, you're making the signs in the air, that's good. Okay, so divide by, you were saying square root, that's what you're trying, yeah?
Yes, square root of 3.
Square root of 3, good.
Good job, Harry.
Good. I knew you knew what to do, I was just trying to make you say it. Okay, so it's divide by square root of 3. What's the problem, Preston?
No radicals and
No radicals allowed in the denominator. I should know this by now. So, Anthony, how do you fix it?
Multiply by the square root of 3.
Multiply by the square root of 3 over the square root of 3. Okay? Taylor, what does that look like in the numerator?
6 square root of 3.
6 square roots of 3. How about in the denominator?
Square root of 6.
Square root of 95.
9.
9, which turns into 3. Remember, a square root times itself gives you that. What did you see, Imani? What else do we need to do? I thought that was a light bulb. I'm sorry. It can reduce a little bit. You see anyway?
Is it a 3?
The 3 goes into both, which gives you
2.
2. So the 6 and the 3 can cancel out.
Yeah.
Not only a 1 left in the denominator, so that doesn't show up. So you get 2 square roots of 3. Now, as long as this thing is something compatible, it'll cancel out something. So you always have to look to see if there is anything. Anthony?
If that was 6 plus square root of 3 over 3, it was really radical.
6
Plus square root of 3 over 3.
If it, you're correct, yes. If it was a plus in here, you wouldn't be able to, you couldn't reduce it unless you split it into 2 separate fractions. Okay, so which one did we just find here?
A. Sorry.
Out of A and B, we found A. We did find S, but that one is in the A spot. So now we have to find B. B is in which spot here?
The 2s.
B is in the 2S spot, right? B is in the 2S spot, and how much is S again? 2 square roots of 3. So this means it's 2 times 2 square roots of 3. And then simplify. How much is 2 times 2 square root of 3? 4 square roots of 3. So here's our B.
we did it.
We did it, yep. All right, good. So once again, we have our answers like that. Here we go. All right, here's another one. All right. The last one, things reduced very nicely. This one is similar, but the answer will look a little different. I want you to be used to doing that. Miguel, which side is the 19 on? The top one, good. S square root of 3. S square root of 3 is where 19 is found. So Miguel, how can I get S by itself? Good. Good. Divide by the square root of 3. So they cancel. Rebecca, what's wrong with the way the answer is?
There can't be that.
Good. No radicals in the denominator. So how do we fix it, Rebecca?
You do multiply the radical of 3 over the
Good. Square root of 3 over square root of 3.
Back up.
and then you do 19 over 9. And
over,
then, with the square, that over 9, but then it goes to 3.
then it turns into a
Yeah.
3. Okay.
Good.
So she said 19 square root of 3 over 3 is our final answer. That's right. Which one is that? A. Good. So it's A, 19 square root of 3 over 3. Actually, I was going to call it next.
Oh, I'm sorry.
So for B, so B is on which side of your template? 2S. So we need to plug in this for S.
So 2 times 19.
Okay, and when you simplify that, what do you get, Alvin? 38.
Square root of 3.
Because it's really just taking it times 2. 2 times 19 is 38. Nothing else will cancel or reduce or anything else. It's not pretty, but it is actually simplified. And so mathematically it is beautiful. Yeah.
Why is it only 2 times 19, not 2 times the square root of 3?
It's actually 2 times the whole thing. But these are not added, so you don't distribute when it's added. It would be like if you had 2 times 3 times 5, right? Would you multiply the 2 times the 3 and the 5? No, you would just multiply 2 times 15, right?
Yeah.
Okay, so it's the same thing. You don't multiply times both of those things, or even if it was 2 times 3 times 5 and it was all over 7. Once again, if you put this over 1, you would just be multiplying 2 times 15 again. You wouldn't multiply it times each part. So it's the same thing back here. You're just multiplying it times the 19, not both of them. And you know what? That's something that's very common to do. Is a lot of times when students see an extra thing like this, for some reason those rules that you would never get wrong if it was all whole numbers get a little bit muddled in your mind. So if you can actually think about these as being whole numbers, that might help solve any problems on that. Okay, does everyone have this one written down? Okay, I know I told you I've got a whole bunch of examples, but I want to make sure we get them. This one actually was a question from a student in the earlier class. So we threw this one in, but it's a nice throw-in, so we'll go ahead and have that. They said, what if it's not the square root of 3? I think they actually even picked the square root of 7. Oh, don't hate them. If you found out who it was.
Appreciate.
What's the time?
It becomes on the quiz.
Okay, yeah.
Is that possible? Like, would that be on a quiz board?
Yeah,
It's
that's
possible.
There is a chance. You never know.
Maybe not, but you never know if it's going to show up on SATs.
Ooh, that's a good one.
So you should just know what to do with this. Which side is this one on?
S squared of 3.
S square root of 3. So 2 square root of 7 is on the S square root of 3 side. So that means that you need to
Divide by.
No, wait, sorry.
divide by square root of 3. I should have put it on the other side. I'll just put it on over here. But we have a problem.
Yep.
Our problem is
No radical in the denominator.
no radicals in the denominator.
That thing flashing is good.
So how do you get rid of it? Times,
The square root of 3.
So that's going to be square root of 21.
What? What looks
2 square root of 21 all over 3. Right? So 2 square root of 21 all over 3.
Any issue?
Yes.
What about the 2? What about the 2?
Happy birthday.
I know.
Okay, the 2 has to stay. So here we have A is that one. A is the one that's the standalone, what we solved for S. So 2 square root of 21 over 3. And then B B we have to multiply it times 2. So B is 2 times 2 square root of 21 over 3, which is 4. 4 square root of 21 over 3. So 4 square root of 21. The thing is that a lot of times students will look at it and say, wait, I can cancel the 3 and the 21, but you can't, because the 21 is under the radical and the 3 is not. So be very, very careful what you try to cancel. That radical completely changes the whole ball game, but this is a very legitimate answer. And I will tell you on your test or quiz, you will have some groups as far as an answer. So let's one more.
Look what you did, Mom. You can't do this.
Get this one written down.
Yeah.
Now I want to go through this one too. All right, so which side on our template here is the 4 square root of 3 on, Frankie?
S square root of 3.
It actually isn't. It's on the 2s side. Okay, don't let the square root of 3 fool you. Look carefully. The hypotenuse is 2s. So 2s equals 4 square roots of 3. Okay, Frankie, then how do you get s along?
Divide by 2.
Divide by 2. So this math's a little easier. No radical in the denominator or anything like that.
2 square roots of 3.
2 square roots of 3. Kendall, which one is that then, A or B?
I don't know.
Okay,
B. Oh,
B.
B.
You see, it's across from the 30 will be the one that's the standalone s. So we found B first this time. 2 square roots of 3. And then that means that A,
S times S square roots of 3
s square roots of 3.
times 2 square roots of 3.
So this means you, now be very careful here.
2 square roots of 3 times
2 square root of 3
times square root.
times, not times square, yeah, times square root of 3. 2 square root of 3 times square root of 3. A lot of times people tend to lose the second thing. This right here is s. So it replaces entirely. Don't lose this second one. It's not part of this. Okay, very, very, very common for people to lose that second one. So 2 square root of 3. How much is square root of 3 times square root of 3?
3.
3. So 2 times 3, 6. In this case, this came out to be 6. So you just have to be very, very careful as you go through. I think that that's it for the lesson. Those of you that are seeing this at home,
What it is.
understand assignment 53 is due tomorrow.